problems up at the top, and let's just see how we did with these ones. I posed a similar question to my pre-calc kids today, actually, this one up at the top, and they were a bit confused about what to do with that negative. Folks, what I would do is I would slide a 1 behind that negative and treat that negative 1 like the coefficient of the variable. So what is our power operation? We have parentheses, so we are going to be powering up. And actually, folks, at the top of this page, let's just practice writing that mad spam acronym. So M to the A, D to the S, P to the M, mad spam. So we are powering up, so we're going to want to multiply our exponents. So distribute to the power of 2, and that coefficient of -1 has its own power as well. So folks, what we have here is that -1 is getting taken to the 5th power. It starts in parentheses, it stays in parentheses. And then the y is getting powered up by 5, and that turns into y to the 10th. Now, folks, what about that -1 to the 5th? You can use your calculator if you want, so parentheses -1 to the 5th. But what might be kind of unnerving is we get a -1. Folks, why are we getting a negative instead of a positive? The exponent is odd instead of even. So normally if we had like -1 squared, it would be a positive 1. But -1 times -1 times -1 times negative times a -1, those would cancel out to be positive, and we would have 1 left over. So we get -1 y to the 10th or just -y to the 10th. Either is good. You can put that 1 in there if you want, or you can just have the floating negative in front of the y to the 10th. Now, on the next one, we need to be careful that we are following our PEMDAS rules here. So we start inside our parentheses. Can't really do anything there. I could resolve that bad attitude, but I'm going to wait until the next step, because my next step, I need to power up on both the top and the bottom. So how many exponents are going to get this power of 2? 2 of them. The k's power of 2 gets it. The j's power of 1 gets it. So that will give me J2 K4. Then on the bottom, handling that exponent, the j to the -1 will get that power of 3. So j to the -3. And the k, with an implied power of 1, will get that power of 3 as well. So k to the 3rd. Now from here, this is where I would take care of that bad attitude. We're going to say, hey, j to the -3rd, why don't you go ahead and go upstairs and lose the attitude? And when it goes upstairs, we get j to the 3rd, and then we have that j squared that was already there. Now for my k's, these are separated by division, so what operation will we use to simplify? Subtraction. So 4 minus 3, we get k to the 1st, or just k. And then my j's are separated by multiplication. So what operation will we use on the exponents? We're multiplying the bases. We add the exponents. So j to the 5th, k. All right, folks. How did we do on those two? The -1 coefficient was tricky on the first one. Following order of operations with PEMDAS was kind of tricky on that second one. Now on this next one, what do you guys want to do first? I'd say lose the attitude. We have division, so I'm going to go ahead and start by sending that b to the 3rd upstairs to lose the attitude. So then we have a squared, b to the 3rd, and now no more denominator. Next, we are powering up, so we are going to multiply each of those exponents by 3. So a to the 6th, b to the 9th. So again, we're just multiplying, subtracting, and adding. But as you can see, knowing when to do what is pretty different compared to how the problem looks. So let's go ahead and take a look at this one. I'm going to give you 1 minute to get as far as you can on this one. Go. That's a good question too.
40.
31.
Oh my.
Also, heads up, I believe Wednesday's an early out.
So we have like 20 minutes of this class, lunch, and.
Oh gosh.
Dude,
Maybe like 25 minutes.
that's why B lunch is stupid.
Lunch is not, should not be. There should be a D lunch.
Yeah.
Wasn't there a D lunch like last year?
I'd rather just eat super late than eat in the middle of the class.
I'd rather go 4 blocks
Carson.
and eat and then go home.
Your opinion is irrelevant to this class.
Thank you.
Damn.
Always.
Evan can't
Time
play
one.
Graham anymore.
Oh.
How do you fail algebra 2? That takes skill. Wait, so he'll retake it with you next year?
I hope not.
Oh, damn.
No, usually they switch up. So you can take Foundations of Algebra 2, which is a year-long course.
Wait, does it look bad on your part? Like, will you get like
Demoted? No.
Like,
All you have to do is
what happens? Do they talk to you about why he failed the class?
Like admin? No.
Like, is there like no punishment other than you have to retake it?
You have to retake it, or if you pass but like didn't do well, then you could take Foundations, which is a year-long Algebra 2 instead of 2 terms. So they cover all the same stuff just in a year's time.
It'll be awful.
Kids gonna be taking geometry in college.
So folks, let's go ahead and start this one. We've got 4 divided by 32.
Semester 1 class.
So we can divide a 4 out of both of those, and that will leave me an 8 on the bottom. Now, we have division going on between these other bases, so I'm going to go ahead and lose the attitude with these negatives first. So we're going to send this one downstairs, and this one upstairs. So the positive ones are going to stay right where they are. So let's go ahead and write what we have locked in, which is the y cubed on the top, and then the 8 and the x to the 5th on the bottom. Then our resolved negatives, x to the negative 2 gets sent downstairs and becomes x squared. Y to the negative 6 goes upstairs and becomes y to the positive 6. So now, instead of having to mess with all that double negative stuff, we just get to add those exponents, which gives us y to the 9th over 8x to the 7th. So, how are we doing with these so far? I think we'll go ahead and go down to, I think we'll try to get through the next 4 problems and then we'll give you some work time. So, folks, it looks like the next problem is significantly harder. Why does it look that way? The very next one. What looks harder about this one?
The multiplication.
There's multiplication. There are 2 fractions. So first, let's go ahead and just review how we multiply fractions together. If I have 1/2 times 3/4, we multiply fractions by going straight across. So that would give me 3/8. So to multiply fractions, you multiply straight across. What you are essentially doing is bridging the gap between the 2 fractions. So I can just change this into one large vinculum. That's what we call the dividing bar. One large vinculum. And then I can combine my like terms and cross things out as necessary. So folks, let's go ahead and start with our number. I've got a 2 on the top and a 4 on the bottom. So I can divide a 2 out of both of those, which will leave me with a 2 on the bottom. Yeah? 2 4 simplifies to be 1/2. Then x is on the top. We've got x times x squared. What will that give us? X cubed. Then I have a y on the top and a y cubed on the bottom, I can take a y out of both of those, which leaves us with y squared. So kind of messy, but we're essentially just taking out GCFs. So what I'm left with is x cubed on the top and 2y squared on the bottom. This y canceled out with the y cubed.
How?
We kind of took it out like a GCF, so we divided it out of both the top and the bottom. All right, folks, so this one, these fractions are also joined by multiplication, so I can bridge these fractions and just multiply all the stuff on the top together and multiply all the stuff on the bottom together. So, folks, let's go ahead and start with our number stuff. And if you want, we can just go straight across first instead of doing cross simplifying. So 5 times negative 2 is negative 10. What about x squared times x to the negative 1?
X.
Just x. X to the first. Now if you're like, whoa, shouldn't we be moving that x to the bottom? We can, or since we end up getting a nice number of 1 on the top, we can just work with it until it becomes a problem. What about y times y? Y squared. Then on the bottom, we'll have the 8, the x cubed, and the y. So if you didn't like the cross simplifying stuff we did on the last problem, you can just multiply everybody together into one fraction first, and then we can simplify. So folks, looking at negative 10/8, what can I take out of both of those? A 2. So negative 5 and 4. What about x's? I can take an x out of both of those, which will leave me with x squared on the bottom. We can divide a y out of the top and the bottom, which will leave me with a y on the top. Hey folks, real quick, does it matter where I have that negative?
Yeah.
So question, is negative 1/2 the same as negative 1 divided by 2 and 1 divided by negative 2? Yeah, those are all the same. They're all equal to negative 0.5. So these are all the same. And the only reason I'm bringing that to your attention is when you're checking yourself on your answer key, just note it doesn't matter where the negative is, just as long as the fraction as a whole is negative. Taking a look at this one, where do you want to start? Should we start by distributing that negative 2, or should we simplify inside the parentheses?
Negative 2.
Simplify.
No.
You can do either. That's what's nice about these. You can start inside the parentheses if you want, or you can distribute that negative 2. Personally, I like to start inside the parentheses just because it's PEMDAS, and sometimes it'll be less stuff to distribute to. So is there anything I can do to simplify with the 2? This 2.
No.
And nope. So that's just going to stay a 2 on the bottom. What about the x's? I can take an x cubed from this one and an x cubed from that one, which will leave me with 1x on the bottom. Can I do anything with that y squared? No, it just goes and hangs out on the top. And now, Mad Spam says we are powering up, so we're going to multiply all those exponents by negative 2. So, pew, pew, pew. 3 different exponents to multiply to. Don't forget about the coefficient having its own power of 1. So y to the negative 4 over 2 to the negative 2. Ooh. X to the negative 2. So it's quarantine, baby. Everyone in the house is mad at each other. So they're all going to go to a different location to lose the attitude. So we're going to send y to the negative 4th downstairs. And we're going to send the other 2 upstairs, which will give us 2 squared x squared over y to the 4th, which simplifies to be 4x squared y to the 4th. So we never want to leave a negative exponent in our final answer. Is our next problem a foiling problem? So what's kind of confusing about this is there is a lot of parentheses going on here, but there's no adding or subtracting sign. There's nothing to distribute across. So all of these things, including the coefficients, are all joined by multiplication. So what I'm going to do is I am going to rearrange this because it's 2 times 3 the same as 3 times 2. We can switch the order of these around. I'm going to put my numbers together, 2 times 3, and then I'm going to go alphabetically. A to the negative 2, A cubed, B squared, C to the negative 2. So because multiplication is commutative, or because we can switch the order, I'm just putting kind of my like terms almost by each other. So then 2 times 3 gives me 6. I am going to add the a's together. So they're joined by multiplication. We add the exponents. So a to the first, or just a. Then we've got b squared. And what do you want to do with c to the negative 2? Lose the attitude. Send it to the downstairs. So c squared. And there we are. And I think we're going to go ahead and stop there in the notes for today. So I'm going to give you guys some work time. And in the purple homework packet, I'd like you to do 1 through 20. That's right.
How do you know if you're right?
Because the answer key is posted on Canvas.
I know, but how do you know if you're right?
I got the bathroom.
I'll just put it up right here. Yeah.
No, but like on the test, how do you know if you're right?
Just say a little prayer. I mean, you could plug in some numbers.